Video, we're going to discuss how circles and lines can intersect and finding those points of intersection. So there's three different scenarios that can happen between the intersections of circles and lines. The first is that they actually never intersect at all, such as in this picture over here. They can have one point of intersection in which this is a tangent line, and then they can have 2 points of intersection where you get a secant line. So those are the three types of situations, and what we're going to do is figure out how can we find those points of intersection on the coordinate plane. All right, so let's take a look here. So the first way we're going to do this is we're going to look at it graphically. Can we find these points of intersections on the graph? Now, the problem with this is it's not always exact as an algebraic approach, but if the numbers hit nicely, then it's really easy to find those points of intersection. So let's take a look. So first off, to solve by graphing, what we want to do is graph both of these things. So if you look, we have two equations here. We have this first equation and the second equation. Now, if you look at these, you should be able to determine that that first equation will be the equation of a circle. And then the second equation is the equation of a line. So what we want to do is we want to graph these two things. So let's first graph the circle. So remember with the circle, we start with that standard form equation of x minus h squared plus y minus k squared is equal to r squared. And h and k end up being the center of the circle, and r is the radius. So if we look at this equation over here, x and y have no h and k values, so that means h and k are 0, 0. So our center of our circle is the point 0, 0. And then our radius, since this value is 4, our radius is the square root of that, so our radius is 2. So we plot that circle by going to the point 0, 0, and then counting 2 up, 2 to the right, 2 down, and 2 to the left. I'm going to make a rough sketch of a circle. The key thing here is that it looks something like a circle. All right. Then we want to draw the line. Now to graph the line, the easiest way to do that is to graph it when it's in that form y is equal to mx plus b. This equation is not in that form, so let's go ahead and make it look like that by solving for y. So we're going to subtract the 2x from both sides. Then we get negative y is equal to negative 2x plus 5. Then we're going to divide by that negative 1, and we're left with y is equal to positive 2x minus 5. So then what we do is we graph that by going to our y-intercept of negative 5 and then counting a slope of 2. So we go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and so on and so forth. We connect up those dots, and you'll see that the line and the circle never intersect. So there is no point of intersection. No points of intersection. All right. First example done. Let's take a look at a second one here for graphing. So again, we want to look at the two equations and first just identify, okay, what type of equation is it? So this first equation is the equation of a circle because there's that x squared and the y squared. And again, when we're graphing circles, we identify the center and the radius. So the center of the circle is 0, 0, and our radius is 3. So we go ahead and graph that center point 0, 0, and count up 3, right 3, down 3, and left 3. And we do our best to make it look something like a circle. Okay. Now we have to graph the line. Now again, we need this line to be in that form y equals mx plus b. So we're going to solve this for y by subtracting the x from both sides. We're left with y is equal to negative x plus 3. Now that y is by itself, we can graph this. They're going to the y-intercept of 3. So let's do this actually. Let's make that a pink equation there. See, this pink's a little thinner. Yeah, let's go with that one. So y is equal to negative x plus 3. And then all we need to do is go to that point, positive 3, and graph a slope of negative 1. So we'll just go down diagonally like this. And so this line would be right there. Now, if you notice, this line hits the circle in two places, right there and right there. So it has 2 points of intersection. And then we want to identify those 2 points. So the first point would be 0, 3. And the second point is 3, 0. So there we go. 2 points of intersection where the line intersects the circle. All right, let's look at one more example here of solving by graphing. All right, so again, when we solve by graphing, we have to look at the two equations and decide, is it a circle equation or a line equation? So the first one, because we have those squareds, we know it's a circle. So we have to identify the center and the radius. So our center is the x value has nothing, so it's 0. The y has a +1, and remember when we take that value out, we change its sign, so that's a -1 there. And the radius, r squared, is 16, so r is 4. Just remember, this is r squared there. So now all we have to do is graph that point 0, -1, 0, -1, and then count 4 up, 4 over, 4 down, and 4 to the left. And then we draw our circle. Again, that circle doesn't have to be perfect, guys. I mean, clearly mine is not. But we do want it to look something like a circle. We don't want a square drawn there just connecting up those 4 dots. And now all we have to do is graph that line of y equals -1. So we just go to where the y value is -1, and let's go ahead and do this in blue. The y value is -1 right here, and y equals is always a horizontal line, and so it's going to be this line right here, y equals -1. Because everywhere along that line, no matter what x value I pick, my y value is going to be -1. All right, so if you notice, there are 2 points of intersection here. Let's go over those. Let's make this green. I think green would be a good color. So go over those in green. That one and that one. Those are 2 points of intersection. So we have 2 points of intersection. And those points are -4, -1, and 4, -1. There we go. That's our answer. All right, some nice examples of solving systems of equations by graphing the circle and the line and finding their points of intersection.